Okay, so I'm thinking about a lot of stuff.
Hmm.
So many things from the planet to the atom.
Hmm.
Uh, Also, another thing that's coming to mind is nuclear power. Um, it's dodgy.
Yeah.
It's freaking dodgy for so many reasons that it's dodgy. Um, you never know, flicking a switch on one that causes one to melt down, especially energy,
Hmm.
nuclear power stations.
Yeah.
Yeah, so
Yeah.
nuclear power stations.
Hmm.
You have to forgive me. My mind is bouncing with a lot of things, and then there's going to be something further come from this. So just let me do me. So nuclear power stations. Uh, okay, so there's many different types of space travel. Yes,
Yeah.
one is all relied on electronics.
Hmm.
So I'm just going to call that AI because it's shorthand. I don't want to write electronics. So we say
Yeah.
AI controlled space
Yeah.
program. Yes,
Uh-huh.
which is risky, very risky. Humans, okay, you've got space with technologies, keep using it. It's beautiful, it's wonderful. However, don't become stagnant. NASA
Yeah.
have a is it called I don't know if it was called SpaceX or Space One, where they had the oh, there's a museum for it, isn't it? It uses the slows itself down so that it comes through the magnetosphere without needing to heat up. It doesn't heat up, so it doesn't need a shell. Okay, so there's a difference. Okay, so my days. Okay, so nuclear power. We're gonna bounce onto that. So this one we're gonna bounce onto in a bit. So AI in space. Yes,
Yeah.
they're good, but they're toxic at the same time.
Hmm.
Rely on this, yes, but incorporate so Neil Armstrong, I said in a couple of videos back
Yeah.
that he said it best.
Yeah.
He didn't feel like he was in control of anything
Yeah.
because all everything else was,
Hmm.
his last bit was that was all he was in control of. Now, yeah, he was making a very good point. I don't even know if he knows the gravity of the thing that he said. And then when sort of reading into that, I'm going to unpack what he meant by it. Actually, becomes a little burst of intuition, premonition, whatever it is. That's a burst. He had a burst, but no one really captured what he said and what he meant by what he was saying. And I'm going to speak for him in a little bit. Like I know he's not here to clarify this or not. Well, you can look at that as he was aboard. I think he was in doing things with aeroplanes and different things like that beforehand. I think
Hmm.
in the American Air Force. I think
Yeah. Yeah.
so fighter pilot or something like this.
Yeah.
Anyway,
He
so
would be.
a bit more hands-on, bit more control.
Hmm.
So let's say then we're going to also add in a CME. Yes,
Hmm.
so corona mass ejection, also known as SF, solar flare.
Yeah.
Now I know that individuals will be like, we'll just put all of the equipment into suspended animation. So the AI goes into suspended
Hmm.
animation, also known as sleep mode.
Yeah.
And this would allow a solar flare to do its thing and pass. Yes, particularly that is how something would operate. Yes, yes, yes. Oh man, there's so much more coming in at the moment. Hang on, just let me just do this quickly. Okay, right. Okay, okay, and there's some more here as well. All right. Okay, okay. Where was we? Putting things in sleep mode. Yes,
Yeah.
that is good for a point, but to a degree. If NASA rely on equipment to come back in and control systems that allow the shuttle, well, shuttle's been retired, hasn't it? Is it? Maybe. Well, anyway, either or. We'll go with the shuttle because it's mainly known. Now, when this comes in, it gets very hot, and you have to rely on some tiles
Hmm.
underneath. I mean, that's very good, but it also relies an awful lot on guidance systems
Yeah.
and AI technologies. However, that's really great and it's admirable, but would there be some sort of protection aboard, let's say, an International Space Station type process. You see, when it was drawing up some stuff, it was from Earth to Moon to Mars. So you have a lunar space station that orbits around the moon.
Right.
You've got some that orbit around Earth, and you have some that orbit around Mars, and these become like the International Space Station, but now around the moon, now around Mars, and you sort of bunny hop between them, where you can have a lot of build from the fixtures. It's much easier to go down to the moon and come back to your base as opposed to come all the way back to Earth.
Yeah, true.
You get more time there, and especially if you're going to be deploying like AI technology, which is great. You want to use AI while you got the chance to use it. AI isn't going to last forever. So nuclear power stations, so International Space Station, if it had something like SpaceX, no, it wasn't SpaceX, was it? I think it's Space One, something like that. I can't remember.
SpaceX would be Elon Musk.
No, it's not that then.
So it's different thing.
Oh, is it Virgin that made that?
I don't know.
Yeah, I don't know if it was. Could be getting confused. Anyway, I should really research what this is called. It's in my mind, but there's an awful lot of other stuff. I'm actually to look back, I might let go of what I've got. So I can't remember what it's called.
I don't know.
Anyway, so it used a system on it, let's say, that would the craft would look like a standard, well, not really, an aeroplane type structure. And when it re-entered, parts of the wings lifted up, which slowed down the descent process, which didn't allow it to burn up. And then when it got past, let's say the ionosphere, I believe it's called, the craft then went back, and then it glides down to where it needs to, and then you don't need any heat tiles. What's more, it's mainly pilot controlled, which is great. If you have a CME in space, you don't have this on the International Space Station, and you're relying on, let's say, one's manual, one's automatic. AI being automatic, re-entry, nice and great.
Yeah.
But what happens if you have a live CME, one that is more like Tunguska?
Yeah.
Maybe, or is it Tunguska? Yeah. There is going to be solar flares that erupt that the Earth hasn't seen it for a very long time, and even then, these events do happen, and when they do, they're long lasting. It's an eruption after another, and it is like nothing you've ever seen. Even, I dare say, putting some things in sleep mode will not be enough. It will knacker the satellites and everything else, which is okay because it can be rebuilt and da-di-da-di-da, and then you start off again. But if you're relying on AI to bring you back in from space, the astronauts are going to be stranded. And what's more, certain things might start shutting down and they're going to need to get out quick.
Yeah.
But without this... So if you had that, like, I think it was called Space One, maybe, or something like that, type process on standby, that if any difficulties were to arise, the astronauts could quickly get into this one and then start the descent back to Earth. So you want to think of it like this. So you've got artificial lights, but you've also got candles. So plants grow under candlelight, and they also grow underneath artificial light. If you take a plant and put it around candles, it doesn't burn terribly. No, it will lose all of its leaves and it will reproduce its roots. And therefore, you might be under the impression that nothing's happening. If you take a fresh seed and the first two leaves that come out on the seed, it will grow and adapt its roots and leaf foliage to make do with that type of light. This is why I think nature is much more advanced than any other life form on the planet, because of its ability to adapt and its variety of light spectrum that it can adapt around. So it can do it under torchlight, it can do it under candlelight, it can do it under sunlight, it can do it on most different lights. You've got CFL, you've got LED. So your standard 100-watt bulbs. There hasn't been any light source so far that I've noticed. We're going to talk laser and infrared. Still likes those. I've not actually tried to grow one under infrared. I've only combined infrared with it.
Mm.
I reckon it'll do infrared as well. I don't know. I'm gonna give that a go. I'm gonna play with that one actually. See what's what. So considering you've got cool blue light, you have yellow light, you have white light.
Mm-hmm.
Candle falls in between the whitey yellowy, and it's also got a bit of the blue spectrum in it as well, depending on how you're looking at it. You can usually see it. I can around the torch if it's on, and nature seems to adapt to this like it's already been there before.
Mm-hmm.
It's a whole lot of knowing that technically shouldn't be there.
Yeah.
So to me, that seems that it's been around an awful lot of stars, which we'll get onto stars in a minute. So lacking of a magnetic field, okay, in low Earth orbit, you're still protected by the magnetic field. Around the moon, slightly in bumps and hits and miss. I think you're more protected by the magnetic field of Earth, which is all very good. If you have a CME happen, and it is severe enough that it brings down power cables, it brings down technologies, become fried, useless. This is a possibility that is to be looked at. And if the world doesn't want to adjust the electronics to be able to cope with this stuff, and even then, depending on the severity of a large amount of CME that is, and then how long it's going to last for, we're just assuming, and technology has been around for a very small amount of time, so it's not been around for very long. So it would be good to think in forward thinking. You don't want to be waiting until this event strikes you before you do something about it. You want to have forward thinking that this event could happen, and then if you're moving away from the star and different things like that, closer to Jupiter. I'm not sure that, you can generate a magnetic field within electromagnetic field is one thing, but to do that and to sink power into it, and if the grids fall apart, and then I get back to nuclear power stations, what happens if you have another event like Tunguska?
Yeah.
What happens to the nuclear power station? If it relies on pumps, if it relies on equipment to cool the rods, if it relies on... and then where are you going to put this energy if an event like this was to happen where electricity becomes not so good during certain events that we don't know about just yet? It's kind of like playing with fire. Don't want to get burnt. So I look at nuclear power stations and I think about it and think, there's a lot of question marks there. Imagine if you have loads of nuclear power stations that are all dotted around, and you have an overdose of the sun's energy. The magnetic field fails, burps, dips, decreases for a certain amount of time. What does this do to your electronical equipment? I think it can do quite a bit, actually. I think it's one of those things that no one wants to ever bring to the front of the mind because it's far too scary to imagine a world without this, and this. So, again, there has been events that have happened. Again, what is the impact if we have a meteorite? Problem is with meteorites, if I'm saying that right, meteorite lands on the ground, asteroid then, is you don't really see it until it rears its ugly head, and usually then it's too late. And some of these objects are pretty damn big. Some of these are massive. It's like, how do you move a mountain? Take one of your largest mountains, and even then, that's a small scale. How do you move that? Well, number one, you need a lot of time. So, in an event like that, even a near scrape is going to have some impact. So, the first thing that would happen if asteroid of relative size, we're talking size of the moon, in shard, that is a bit more elongated. If this brushes past the planet and skims it, this is going to cause lightning strikes like you've never seen before. Lightning strikes on electricity, electrical items, wipes the device. Snap a spark onto a phone.
Makes it just piece of junk.
Yeah. And so far, when we've taken these to engineers or whatnot, and say, yeah, can you fix this? They can always come back with that they can't. But it's all right because there's plenty more. You can buy another.
Yeah.
The object wasn't for me to buy another. I'm well aware that I could buy another. The objective to that was I want to know how you fix this. And then it comes back that you either A, you don't know how to fix it, and it's not criticizing. It's I want to know where your level of intelligence is on fixing this, your capability of fixing this. And therefore, you are taking it for granted that there is a store that sells multiple of these, you best just buy another one. That's not the challenge. I'm well aware of that. I want to know whether you can fix this. Because in the event that meteorites don't have to hit the planet in order to do damage. So we take a look at Io that's around Jupiter, and that's what, discharging around 3 million amps.
Yeah.
If Jupiter had any water on it, this would be separated as hydrogen and oxygen by now.
Yeah.
This would have separated. I'm sure it would have caused an electrolysis type process, and this would puff up the atmosphere. So you could say that Jupiter had a liquid on it. It doesn't receive as much heat from the sun because it's, after all, it's quite far away. Although it's bigger, so it is accumulating some of the stars' radiation, which is then converted into heat. But I think most of its heat source is being driven by Io, that is discharging this energy, and this energy, which after all, has caused a lot of heat when you have lightning strikes.
Yeah.
You got to think about it. The more lightning strikes you have, wow, doesn't it feel hot?
Yeah.
It's really, everyone says a good old thunderstorm cools everything down. Yeah, it does. But when it strikes into a lake, think of how much. And always the ground is usually, unless you've got a dry storm, the ground is wet. So each time the lightning strike is making contact with the earth, it is, hence why nature loves it. Nature seems to be telling every human on the planet something. Hey, have you not noticed how big I grow when there's lightning? Again, this shows that it has experienced this before, perhaps more so than we understand. And then meteorites or comets, asteroids, whatever you want to call them, sort of circulate bit by bit, bit by bit, bit by bit. And this causes the discharge. Again, I'm on a great belief that moons, the influences of the moon, although the moon is quite far from us when we think about it, it is still stretching the core or the crust. You see, I believe, yes, that the moon influences the tides, yes, in however you say it. But I'm also under the belief that the moon is pulling the crust up. It's a lot faster than the star, I would say so. I see it at night, and then I see it during the day, and I think, wow, you're really moving.
Yeah.
And this has an influence on the crust, and water must respond to this slight lifting. You always notice that you either get a higher tide, or if you think about it, if the crust starts to bulge because the moon is there and you've got a large amount of water, it's not going to be able to run back as good as it usually would. It's going to bulk the land up to sort of envelope it. And yes, then when the peak is breached by the water will then flow. And I reckon this is what causes those more severe tides. I think it's lifting because we can't see it. And I think it's very subtle. But how much movement do you need in water, if you've ever tried it, where you stick no air, but you flatten a bag in the bottom of a fish tank? I've done this, glued it down, actually silicone, and wait for it to cure. Oh my God, it stinks. Salt and vinegar all the way. And when you take the bag in the water and you slightly lift it, when you fill the fish tank with water and you lift it, notice what happens to the water. And then if I move it slightly, and I break the surface, again, it reminds me of tide out, and I start to cup it and bring it over this way, the water volume lifts up, and then it breaks that crest. It's not noticeable 100% if you're pulling it completely out of the water like a freaking mountain and moving it. This is really great difficulty because it has to fill up with water, so you have to put holes in it as well, so that but again, still, it's some water is escaping through there, but majority of it bulks up, then breaks the crest. And I'm not even breaking the surface, technically. And you think about the moon, to me, the moon is like a bag that constantly moves around the Earth. That's the way I see it. Triangular shape. Well, it's not really, because it's more smoothed in all directions. but it sort of peaks the crust slightly, and the star is doing it, and Jupiter is doing it. Oh man, it gets so confusing when you add in all the other planets that are nearby. They are influencing the Earth the same way that the Earth is influencing them.
Yeah.
So I think that this internally is that stretching and squeezing of the metal, which then causes it to get very hot. And you keep doing this over the time that the moon has been in orbit around, is causing that internal heat again, which I think this is why Earth hasn't cooled down. You know, when we look at Mars and they say, oh yeah, it's cooled down because, you know, it got hot, all of the planets got hot. No. I refuse to accept that. Mars has cooled down and it isn't that much smaller than the Earth. Earth would have been cooled down a long time ago. What's the difference? Well, Mars had a moon. We know this because Phobos, Deimos, you could say that they're asteroids that have been captured. That sounds all very good and easy to explain, but I think it's far more complex than that. I think it had a moon. And when you add up the Kuiper belt, I believe it's a Kuiper. Oort cloud is the one that goes around the star. Yes, the Kuiper belt, there's debris in between Jupiter and Mars. I believe that when I asked the question of when you gather all of these particles back up, because in my mind I hoover them up and crush them up and then add Phobos and Deimos to it. One of those is the asteroid, no doubt. And you formulate these. It's a slight bit bigger than the moon, or slightly. It's not far from what our moon is. Now, whether that is hollow or not, then how hollow that was, is Mars the old moon and there was a planet that was bigger, depending on how hollow it was, different now. And I think that that's what kept Mars's internal heat source going, which, i.e., its magnetic field. You know, and I think that when something hit the moon, the prehistoric moon of Mars, a lot of the shards went into the planet. A lot of them went out into make the Kuiper belt. So yeah, I was picking up the pieces in some areas in Mars. If it had water, it didn't erode very much. Therefore, those objects came after. The rest of it seems so dune-like, which is characteristic of water, and a lot of it at that. Now, whether this was carbohydrin or not, that's a different story entirely. Whether it harbored life or not, again, well, I think it did. It was taking effect. And I think an impact smacked into the moon and obliterated it. This caused it to erupt the core. The core had an instability. 1 minute it's being pulled and then all of a sudden something lets go. If it's pulling on the crust and it lets go at that fast, it's like an elastic band letting go at a tongue.
Poof.
It just disappears. I mean, you know, that force that was pulling on the crust just lets go. That would explain a volcano eruption, which would be, what, Olympus Mons? A few others in the process. That rush back, oh, I bet the ground was shaking on Mars like nothing has ever been seen before. And I think the core then exploded out of this. This is why it looks the way it does. To me, it makes sense because it's just the way I see it. I run this in my mind. Maybe it's just because my mind wants to see that, but I don't think so. This is then what led me to... It makes me uneasy that we you know, it seems so easy. Okay, we can do something about asteroids that hit the Earth. And then someone comes along and says, yeah, we also got to include the moon. That becomes very problematic. I mean, think of it in another way. It's like removing one of the planets around from the sun. If you don't think that that's not going to have an impact on the sun, the star, the center star of any solar system that is out there, that is going to have an impact. You're taking away something or you're breaking down its mass. This has an impact on the star. And I believe that in an event like that, so then it gets more confusing and then it starts to make sense. It's too easy to say that we'll just protect the Earth. And then it's too easy to say that we'll just protect the moon. Man, what the hell are you on about? Well, it's easy. Now you got to protect all the planets. Well, Jupiter seems to be doing a good job of this, and most of the bigger planets. But again, imagine something that was big enough that smacked into Mars or smacks into Venus. I mean, we already had an event once that happened on the Earth. It's written into the archives. Now, whether that was an event because of a supernova exploded, the Edwardian time, my differences on that is, I don't think it was that did it. I think it was the own star that did that.
Mm-hmm.
I think that a lot of stars will protect themselves against gamma rays.
Yeah.
I think, yes, they're going to influence, but a lot of it wouldn't make any sense as to why you got a magnetic field.
Mm-hmm.
A lot of this stuff is going to be lots of it, and then many magnetic fields. You don't just look at the sun. When we look at the heliopause, you've got to take into consideration Jupiter's magnetic field. Although it's small compared to the sun, it's all of these magnetic fields all together. So to have Mars where it doesn't have a magnetic field, you've just diminished the sun's overall output, because I think the magnetic field is combined.
Yeah.
If you think about it, if you have one electricity pylon with one cable, it's generating an electromagnetic field.
Yeah.
Now you add two.
Mm-hmm.
Well, does it add it? Does it add to the field? Does it make it more potent? I think it does. Then if you add 3, 4, or 5, or 6 of these, it's no different than if you have one supermassive electricity cable running, and just that's the equivalent of the sun.
Uh-huh.
Then if you add a few smaller ones around it, well, you might as well. There's energy there anyway.
Yeah.
This helps you get around the fact that sending large amounts of energy costs you energy to send large amounts of energy. Well, the more you have in a group, well, they use that pretty much the most of the space around the area. The energy isn't sent through a cable, nor is it technically sent around a cable, technically shades of grey. But in between all of this, where you have multiple cables, I think this is why they're so highly sought after, but most people in communities are like, we don't want them. Yeah, okay, that poses a problem, because to send loads of little cables is very, that's detrimental to the, you have to put a lot more in to get the energy to go, when you've got a lot of them in a mass. So yeah, when we get back to the start, we'll take the thicker core, and that's going to generate an electromagnetic field. Now we're going to add a load more around to it, and this is going to increase the electromagnetic field. The same thing we'd want to look at as our star. The star is generating one. So a star on its own, oppressive magnetic field, wonderful. Now you start adding planets to it. This is why I believe that neutrinos have the most biggest magnetic field. And what do I say? I always say that they have more planets than any other star. Not just do they have more planets, they have more planets with more electromagnetic field. And I think that this is what causes the neutrino star to convert into a black hole. Again, something explodes and removes all of a sudden. This one implodes. I think there's so much pressure there. There's so much energy, and energy is being created in a way. So let's take a look at the atom.
Yeah.
What happens if I have more electrons? Have I got more of a powerful atom? Well, if you say that these are minus, these are plus, and you've got more in the nucleus, so you've got 6 per 6. If I keep on adding and adding and adding and adding and adding, isn't this what nuclear fusion is all about? But then what happens if I add external energy to this?
External, I don't know what that is.
Yeah, you see, that's another question. Again, this was moving on to something else, and I'm going to have to come back and go full circle with all of this, with where it all links. One of the other things I wanted to talk about was, what happens if I added a magnet to this, which increased? So let's say if I had an atomic... No. Yes, an atomic... No, is it atomic on the atomic level? Where I magnify? Could be atomic. I can't remember if it is that now. Yes, I think it is. No? It is. No? Magnifying glass, one of the powerful ones, let's say. Whatever, so that I can see these. What's that? An atomic microscope? Anyway, whatever it might be. Let's say if I could zoom in and I could see this very clearly, and I made some instruments that were as thin as... let's say it's like an egg and a sperm, and I can artificially inseminate. Is that right? No, because that's not artificial insemination, is it?
If you have sperm and egg, yes, it is.
And I'm underneath my microscope.
Yeah.
Microscope, yeah. And I have the tools to breach into this and then drop in a sperm and remove it out. Maybe I'll put in 2. I don't know. Maybe try and make the egg split or whatnot. Anyway, that's getting confusing because we're adding twins. Well, technically you have to divide the egg first. Anyway, still, let's say if I could do the same thing with this, and let's say if I could increase the magnetism of these that are dancing around. Let's say that somehow I've made a magnet that is liquid.
Yeah.
And I know that it's all minus charge. And I drop it around there and increase its mass. And I do the same with all of these, but at the same time, I would need to increase the mass of the ones inside the nucleus.
Yeah.
Now, I'm going to make that atom from minute, and eventually, if I keep doing this process, I'm going to be expanding this atom.
Yeah.
I'm going to be making it bigger.
Yeah.
Therefore, am I going to be increasing its electricity? Let's say, its overall, a motor. Think of a motor as pretty much...
Yeah.
You think a motor comes from the same understanding, yes?
Yeah.
Oh, I could be mistaken. I think a motor is pretty much the same process as this. So you add more power to it, the motor, so therefore I'm adding more power. Or you can choose to use this as a dynamo. Often this can be put into the wrong hands because this wouldn't be very good for so this makes a heavy atom. Think about it. This is making a heavy atom. It's kind of weird, isn't it? So in order for your body to exist, you have to eat food, yes?
Yeah.
So technically, are you feeding the atoms?
Must do. Atoms make the cells.
So you're giving it an energy. So somewhere in your body is using this food and finds a way to increase the longevity of your... Very interesting, isn't it?
Yeah, it is.
So you would need a governing heavy atom, multiple ones, in order to govern the less heavy. So would these ones then, if I started to make this heavy atom, would all the other atoms that were around in standard motion, would they begin to feed energy into this? See, I got lots of questions. I got so many questions. So the smaller ones would then be governed, but would they begin to start doing something in an orbit that was very strange around this heavy atom?
Yeah.
Is it going to accumulate more? Right? We understand about splitting atoms.
Yeah.
Okay, so I'm not into that. I'm into adding mass. Okay, everyone wants to split atoms. I want to see if we can make these bigger. And therefore, what type of power can you harness from that? Makes me look at it as stars, technically, and moons. Moons orbit around. The more moons you have, take it Jupiter, for example, with its Galileo moons, the main moons that you see, it's rather close. I mean, impacting its ability, if it wants to spread out this far, and you push these to come closer to this center, which is like having the moons of Galileo that you see around Jupiter.
Yeah.
Well, the question is, what happens if you push all of the moons closer to Jupiter? And they start discharging this energy onto Jupiter, and then Jupiter starts creating a really bigger magnetic field. Could we make Jupiter's magnetic field more bigger by moving the moons closer to create more friction? And then what happens if I start making the moons more bigger and thus Jupiter more bigger? Am I going to start fusion process? Everyone wants to work out this fusion process, correct? Nuclear fusion is the godfather of all breakthroughs, right? Anyone that is capable of creating nuclear fusion will probably be left like a piece of furniture and have statues made after him and everything else. Okay. Well, when I understand atoms that make up all of these objects and they start to behave like atoms, and now, if then this starts to increase, what happens to the sun? And then if I were to move Jupiter closer to the sun, or I start to gain mass. So here's a question for you then, all right? Everyone is so obsessed with mining from this area and everything else. You know, good things come from when you mine and bring resources from outside your planet and bring it to the Earth. Yeah. two things you need to do. Well, one is you use the Earth, but yes, you also are going to need to gain the mass on the moon.
Yeah. Mm-hmm.
When you begin to expand, so you've got more than any resource that you need at the moment, store it on the moon.
Mm-hmm.
Moon becomes a storage facility.
Yeah.
This is surely going to interact.
Mm-hmm.
The mass is increasing on the Earth, but also so is it on the moon. Now, let's take this, for example. So, any ETs would understand this. This would be a beautiful thing. You know, if everyone's looking out for ETs and everything else, go and look in the mirror. Okay? Because don't ask the question of whether there is any ETs. Absolutely. Go look in the mirror and ask yourself the question, do you want to become ET? That's a better question. That's a rich question. One is in the mystery, oh, yes. That is a question that will only ever lead you down a road of not very good. That's not empowering. That's actually disempowering. I don't even know if that's a word, but it leaves you not in power mode. You want to go and ask yourself a better question in a mirror is, do I want to be an ET? And then watch your whole population change, because the answer is going to be yes. What you're saying is when you're looking for spaceships is saying, I want a spaceship. That's the whole of what humanity is doing, but you're asking the wrong question. You're not bringing it home. Bring it home. What was I saying? Ah, yes, there we are. Thank you very much. So if you were to gain, let's say, if we were to go to another solar system, which this is something that the Earth needs to calm down. Yes, the Earth itself. Not about humans, nature, or anything else. This one's just for terror at the moment. The best gift that we could ever give Terra when we are done with her, and this sounds like a horrible thing to say, right? Is we ought to honor the call. If she gave us life, which she did, and allowed us to harbor life, then we have to bring her up into a star. We have to make her a star. But it's not going to happen. We're going to have to put a lot of safeguards on it. I think it's one of the beautifulest gifts that you can give back to your planet is to make her into a star. And not just any star, but a neutrino. Think about that for a second. It's a hell of a gift. It's a gift of eternity. And then that gives you enough time to figure out how to convert black holes back into a star. And then the star... So Earth, essentially, will always come with you. Think about that. Plus the moon as well. You'll need one on the other, one on the other, one on the other. Might as well go with these gifts that have, well, spoilt the sight over the nights. Earth, no one ever truly experiences darkness. Not on Earth. You don't ever experience that. Did you know the stars are much more brighter, but you just don't realize it? Atmosphere scatters light. So even on the night side, it's not really night. The day has just got dim. So when you say night and darkness, this is not truly darkness. You know when you go inside a cave and you turn on a torch? That ink blackness. Again, it's technically not even technically dark unless you block off the entrance completely. And then some. And you notice how the torch just does not do any justice down there at all. Turn off that torch and just sit in that and see if your eyes adjust to that inky black. That is true definition of darkness. Now, the strange thing would be is if someone was in a cave for a bit and they came out at night, the one thing that they should be wowed by is how bright the stars are. That's interesting. If the sun disappeared completely, no explosion, no nothing, and we just wrapped it in darkness, it was eaten by a black hole, just like that, you would realize that the moon wouldn't be the thing that takes your focal point. Maybe it would be the stars. You would wonder how freaking bright they are, and eventually they'd become so bright to you that you'd be drawing curtains to block out the light. Light is about adjustments, and adjustments is about so the same way the plant adjusts to the light, you also adjust to the intensity or the lack of it. People that go from one star to another star will notice its differences immediately. So, well, I guess if you could teleport from one star to another immediately,
Yeah.
you would shield yourself, and it would be like, too bright and everything else or whatnot. But the next generation that were born would know no different.
Mm-hmm.
And you'd still be a bit, oh, I remember a time when we were around a star that wasn't like this. It was beautiful. What do you mean, Grandad? These younger kids growing up. And if you were to teleport those same individuals that have been born around this new star back to this star, which that's better, they would be, this is something. That's the adjustment. So like nature, when you were to take a plant from outside and bring it inside, immediately it'll drop its leaves. You'll be like, it's dead. It isn't. It's not. It's checking the environment and saying, right, what have I got to work with?
Yeah.
I got this type of light, right? Okay, so I'm going to need this type of nutrients. Okay, so I'm going to need this type of root.
Mm-hmm.
I often wonder whether the types of roots on plants, they all have specific roles. Well, you're going to go over there and drink this one for me because I need some of that. You're going over there, I need a bit of this. It's all there within the nutrients, I'm sure. A lot of it doesn't need. And you'll be like, nah, it doesn't need that nutrient. Or does it? Or is it just it doesn't need it because it's getting it from elsewhere and can mix these ingredients together in order to come up with what it needs, X, Y, Z, which is growth and different stuff like that. But once you remove a certain thing that worked well in the beginning and you bring it indoors, same soil, it's got to create new roots. Therefore, it's got to go for different nutrients in order to achieve the same thing, which is life. It might be a bit smaller. The fruits might be a little bit more less that particular season if it's already in flowering and fruiting production. We're not putting one brand new in and got to wait a few seasons before it's... Again, I think that's learning. It's got to learn which way to mix things. I don't think flowering just comes to it like this. I think it's a case of... And it usually is pretty quick. Plants are pretty quick.
Yeah.
They spend the time mixing the ingredients to get the right outcome.
Mm-hmm.
So they play around.
Yeah.
I think that's what they do as seeds, is they're learning this. Yeah, and some of them already have this built into the seed. They just have this knowing, hence why autoflower is a different thing altogether. But anyway, so so much like you have planets and you have lots of planets, if you were to take the Earth and put an awful lot of mass around her, I mean, it would be quite the thing, right?
Yeah.
If you're able to travel here, there, and everywhere at pretty quick speeds, your equipment seems to hold up for it. Yeah. You're going to be doing more things than you imagine you're doing now. So now it's like, go to work, earn money, do this, grab this, resource this, mine this, need this, calculate this, bring it all together, and what can I create with this stuff? Well, I can make mobile phones, I can make cars, I can do this, get power, electricity, cables, and so on. Mm-hmm. When that time is done with, which is hard to believe it, right? Because this is like futuristic, but generations have done it. You put down stone tools and then grab metal ones. Yeah. You took away flint tools and you also took metal ones. Yeah. In some cases, they still use stone, technically diamond. Mm-hmm. Yeah. Diamond is great for drilling and different stuff like that due to its strength, and it can cope with pressure. So therefore, diamond piling machine that's getting down more to the bottom of the... you'll be able to grind through quite a lot of stuff with that. So you can get deeper in the ground. Yeah. Don't know if you ever want to. There'll be a lot of sounds in there due to the water hitting into the chambers that then evaporate, and when the steam rushes up really quickly, it goes through certain fissures. It makes a screaming sound, much like an organ. But because it's out of tune, because you've tuned instruments, you might put that down to being ghosts and ghouls and pits of hell, which it isn't. It's the sounds of earth. That's what that is. And when you drill into something, you have made a chimney. So these gases escape quicker. Yeah. Actually, they don't even escape because they cool down when they reach a certain, depending on how deep you are, and it condensates, and then this water falls back down again, and if it hits the heated area, when one is whizzing up, some more is condensating, it's coming down, so, you've got this runaway effect of sound, so it's really interesting. But so when all of that is gone, and you've got more capabilities around, you're going to be experimenting with more stuff. What did you experiment with on Earth? Quite a lot of things. You're going to be asking the question, what happens if I add more planets to a solar system? Yeah. Well, you're going to find out. And then looking back on that, you'd be like, if only we did that with the Earth. Wouldn't it be nice to experiment with Earth? Again, this is very futuristic type thinking. It's actually probably doesn't serve a purpose for right now, but still, it's still one. It ensures that terror is going to be looked after in that. Yeah. You know, if the star starts to show signs of, you know, by that time you'd have already built enough stuff to already be away. Every human off the planet, every single thing that you ever, you know, the way the garden on Earth is,
Yeah.
you want to be sort of lifting all of that off. All that life that is there, lifting it off and then recovering your structure, whether it needs changing out in a future, that's probable. Whatever gets you started.
Yeah.
You know, to stay here is not going to benefit anything.
Mm-hmm.
So you need to lift the life of carpet off the earth and then reprint it into something else, onto something else, inside, on, depending on what you build. And then you'll move this away and earth will become bare. So I was talking about an event that happened back at the Edwardian time.
Yeah.
I think something big hit Mercury, and Mercury was quite big.
Yeah.
Lost its... This causes something to let go in the star. I think so. And I think this is why certain meteorites that fly by the sun also have an impact. Very weird, but it does have impact on the rest of the planets, because you've just gained some mass, and now you've lost some mass if it throws it out of the... I think this is why stars like to hold on to things that are too big. It'd rather have it circling between the planets, which is orbiting. If it can get it to land gently, depending on what those are, it wants it.
Yeah.
At the end of the day, it wants to get bigger. And if it gets bigger, again, it becomes a neutrino. What does a neutrino mean for a star? We all go black hole. You are ensuring you're going to live beyond your star capability. I don't think anyone wants to... I think that when it reaches the giant stage and it puffs off its last one, becomes a dwarf or a brown dwarf, it's still not over if it gains mass. Think about it. If it eats on its way something that contains a lot of hydrogen, this should... Well, it's not going to give it enough time unless it has a large amount of hydrogen pushed into it, let's say. It knows how to make that hydrogen into a process, into a process, into a process, into a process. If it gets enough of it, I'm pretty sure the star would reignite. And then there's types of star building. One, nebula. Okay, this one won the race, but all the planets line up. They want to become stars. They all want that. Now, whether they make it there through... So we see binaries. I think there's more than just binaries. I think just in your limited field of view that it just shows you, and it appears like it's everything, because that's a very it's very hard to explain it, that it's a very limited... It's a tip of an iceberg, even though it's not. It's a pin on the tip of an iceberg is what you see. It's pinhead. It's very small. It's very limited field of view. Beyond that scope, there is a lot more. That's why science must never be closed vision, tunnel vision. It needs to be open to possibility. So you use the word think, maybe, possibly, could be, until further information comes in, X, Y, Z, then we'll adjust course. So when I look at stars and planets and this discharge of energy, 3 million amps, different things like that, could you imagine if Earth had 4 moons? So let's take that for quickly. I think a few things would happen. Is this energy has got to be dissipated. So if you've already got a hot core, and the core can't exactly get any more hotter than it is, if not, it will start the fusion process, which undoubtedly I think is what it wants, but it's not big enough to sustain that. Because each time, the reason why it's not sustainable, think about insulating the Earth with large amounts of more rock, and you've got that small fire going. What do you think will happen? Well, it's going to take a while for that to radiate through into the next colder object, When it gets to a certain size, I think that this overall size then is what triggers that ignition process. And then think about it, the atmosphere. So Jupiter, very small interior, very puffy exterior. Then if you look at any of the gas giants that are further out, they seem to be hard frozen, not much of an atmosphere. Imagine aiming a magnifying glass at that and thawing that out so it's no longer in a frozen state, let's say. How big an atmosphere do you think that would have? Again, that's going to add some large amounts of pressure, along with a lot of moons, which keeps this sustained. This excess energy then is thrown out into a magnetic field. Now, what's that for? Why does it do that? And it chooses to use that energy that way to bring in more matter. If it is going to be aware that there is north charged comets and southerly charged comets and a bit of in between, if you have a magnetic field, what do you attract more of? More mass. It's no good being a small star. Well, you could be a little dwarf, but what's the point in that? That doesn't work. But hold on to what you've got and accumulate it. A bit like humans hold on to what they've got and accumulate it. Nature holds on to what it has and accumulates, tries to get bigger and bigger and bigger. This is growth. Everything is trying to grow or hold on to something, and you outgrow yourself with lots of, you take more land, and this type of greediness seems quite natural, but it is too natural. It's animalistic. Well, if you think about it, accumulate is usually money, so that's not so bad to accumulate money if you were accumulating lots of things. Could you think that human hoarders would be a better? We're the hoarder kind. Rather fitting. If the shoe fits, Cinderella, I'm definitely going to wear that. Planets are a bit hoardy the same. But what happens to these atoms if you add more to them? I just wonder what does it do?
If you can add more in the inside and outside, you make fusion.
Okay, but if I added enough, am I going to generate some sort of field around here?
Yeah, you are going to create
Then
different...
what happens if I make my nuclear power stations out of these heavy atoms into all of the material that's around? Is it going to generate a magnetic field that if the Earth's one fails for a bit or burps for a bit, is it going to protect what's inside it? What about if I make the power cables out of these heavy atoms? After all, that's what they are. Is atoms, yes, that formulate objects. You see, it starts somewhere, and then what happens to a computer if I make all of the parts out of these heavy atoms, and these are the natural atoms, but these are now the newer atoms that are man-made? That sounds bollocks. Human-made? Well, it's technically still not man-made or human-made. It's universally made through you. So it's still part of the universe, although, I don't know, I draw the line with chemicals. But what happens if I make these out of this? And then what happens if you were to make a human out of these atoms? It's a very weird question, isn't it? That's a very strange question. But if you're going to make nuclear fusion, haven't you got the leisure of stopping the process at certain times?
I have no idea.
Is that what causes the biggest explosion on stars? Because it's like a nuclear bomb. Think about it. Does it then split apart all of these atoms or not? And then how many in a star explosion is lost because of splitting atoms in this explosion? Yeah, anyway, I'm asking really weird questions, aren't I? The ones that you don't have an answer to.
So we have fission in nuclear power plants, don't we?
Yes, fission.
And fusion shouldn't make radioactivity, should it? In a way?
Okay, yeah, so fission then, if you want to say it that way, more about a star is more fusion, isn't it?
Yeah.
So what happens if you then begin to fuse these together?
Then there is no fallout, is there? If they are gaining mass.
Yeah, and then what happens if you make objects from these? If you can contain this in a way, I mean, what would be the difference between star-made iron versus your-made iron via combining these types of atoms together? I don't even know if that is even possible. Maybe I'm thinking out of the box completely, and I don't understand it quite right.
Should there be a difference?
I don't know. I'm often wondering that. Fusion is fusing two things together, yes?
Yeah, fusing more parts of the atom. So it would have to go. I don't know how it's in the nuclear cycle.
Well, after all, then you would ask the question of how would you fuse these together? Well, probably use the temperature of the star. You see, your experiment in a lab is only going to be limited to what humans can. My money's on a star. If I could find a way to put these objects into the star without the outer case melting or disintegrating, and aim for it to fly into the center of the star, where the pressure and heat, after all, that's what you need, is a lot of pressure and heat. But allow that pressure and heat in, but don't allow this to dissolve. So that when it comes out the other side, I can much more easier see this once it's cooled off. And then if I open it, then I'll have a success or not successful. Then if I put it more into the star, I'm going to get a different result. If I pull it more further out of the star and skim the, let's say, the skin of the star, that's not much pressure, but there's still a lot of heat. But that's going to be more heat, more pressure, more heat, more pressure, more heat, more pressure. So if I did it here and learned the process, would I make iron? Here, would I, and then let's say you'd make helium here. I don't know, I'm just going to put it like that. If I actually write high, whatever. I'm just going to keep it like that, H. Maybe I do it a bit bigger. So let's say, would I make helium here? And would I make iron here? With my atoms?
Something like that would be.
And then if I was able to manufacture these in a lab to make them a little bit more bigger, what do I get out of this process? Because this would then be a fusion process, yes, of atoms. And then using the star's natural density and heat, which would then be pressure and heat. You see, experiments would move. At the moment, it's all here on Earth and what you can do with your bare hands. And I just find this fucking weird because it's difficult to do that. It becomes so overcomplicated. This seems easy. Might as well go with the flow with the stars. Well, they already got the heat and they already got the pressure. Yeah, if I put something here that's metal, am I going to be able to shape it? Using the old ironsmiths would have to use fire and blow loads of air into it, or I could just use the star. It's there. It's lovely and hot anyway. And then use the robotics while you got the time. But there again, would they fail? Probably. Would they not? Then there's going to need to be some things to overcome. Then what's signal going to be like? Interesting. And then atom computers that work on the spinning of one, spinning of the other. I would get this data from outside what's going on inside. When that motion stops, I'm not sure. When it starts responding in a more of a natural way, that experiment didn't work. The sun managed to... Because it would stop giving you these signals back. Yeah, I'm often wondering with this. And then can I stick things on atoms? Stick something here and here, and stick something on here and here. Can I encase it? Can I encase this with something? Can I make it heavier? Can I make it denser? Can I make it bigger? Well, loads of questions, really. Got lots. And then what happens if I use the star? Can I send in a big container full of carbon and then convert this into something else? Go through twice, and can I convert that into oxygen? I mean, lightning seems to separate, but also bring things together as well. That's kind of weird. That's yin and yang.
Yeah, it creates ozone, doesn't it? That's
yes. But first, it would have to separate water, which is liquid, in order for it to then start binding these together. So it's technically, it seems like a large amount of atoms collected together, which make the sun. And their energy, which I would look at as lightning, much like Jupiter and Io discharging that energy, is the same thing happening here. But because they're in a star, all of the atoms are compact so tight together, they're orbiting each other, and they're letting out these discharges, much like if you have Io that's really close to Jupiter, is discharging all of this energy. The closer it goes, it's going to be releasing more electricity, the sparkle. And is this why the star gets so aggravated that it begins to push them so close together towards the center that this is what causes the fusion process. And the heat comes from this electrifying. Yeah, if I had to guess it, I say that there's energy being made here.
Yeah.
And the more you compress it, the more this is becoming aggravated, therefore heat. And then this is releasing a magnetic field of its own as well. So therefore there's got to have a core of this, and this. Lots of questions, really. I got lots of questions. But yeah, so nuclear power stations. And then if I were to get some heavier elements out of this that were a bit more compact, a bit more tighter together, and I were to build structures from these, would they emanate because you froze it in that sort of compact area? So on the atomic level, I have empty space, yes?
Yeah.
What happens if I compress that empty space? If humans were too close together and there wasn't that much empty space, we'd be freaking hot.
Yeah.
We would be generating all sorts of... this would interfere with... Life wouldn't work that way. But I wonder what happens if you compress it slightly. You're going to get some excess energy, I'm sure. So they have to be in this sort of distance. And therefore, in the womb, you're cooked under pressure and heat. I just wonder. I do. There's something else coming. It's going to come back again, I'm sure. Yes. So if I take some objects, and technically iron that we see is suspended animation.
Yeah.
If you think about it, because it's more better form would be molten inside a star. So if I compress these together and then pull it out of the star really quickly, and then it, what we would say, cools, would I keep them then in that more compact? So if I looked in the atomic microscope, I'd notice that empty space was a lot more, usually it's this wide, but now it's this closer to it, and it's now doing something different. It's now emanating a magnetic field. It is now hot, or it's warmer. What is the change there? There's going to be a change. Then likewise, if I separate these a bit more, do I get more of a plasticity object? Can I make a plasticine iron? Most things in here, I agree. Would you agree that they're molten?
Yeah.
And if you were to take it out of there really quickly, it then becomes like frozen cast?
Yeah.
Even though it doesn't make any sense. But it all depends on where the natural state of the elements actually is.
Yeah.
We might see iron on a planet and think that's its natural state. Technically, it might not be. It could just be super cooled.
Yeah.
Usually it belongs in these things.
Yeah, it might be liquid state that is natural.
So black holes are basically like jacks that separate these and defuse, and stars fuse.
Yeah.
So, and black holes might take a little bit longer to chew on a piece of iron and go backwards from the periodic table. So you see the periodic table as one way of what stars can do.
Yeah.
And a black hole goes in reverse.
Yeah.
So if it takes a piece of hydrogen, it's if it takes a piece of helium, it will convert that pretty quickly into hydrogen. But if it takes a piece of iron, it's going to take a little bit longer to chew on it. But still, once it gets through, it's like pulling teeth, I reckon. So it does the reverse of what a star does. It's the reverse of. Picks apart, crushes together. The problem is with stars run away really quickly and then end up creating a black hole out of default. And then where the black holes then are few and far between, they then begin to start being productive more and more and more, which then outraces the stars. But black holes, a good thing about them is that they eat each other. They're cannibalistic, and then they explode as one. And then the process starts over again, and again, and again, and again, and again, until the experiment is turned off. But why would you want to? How many different variations of cooking? And then this makes you think about collective in a different way. Could they tweak it each time to be more separate, more compact? Could they take a life form that was rose up this time from one that rose up last time in the cycles, and then try and combine these together? And then if these are combined together, how do they respond? What's their evolution ratio? Isn't that an amazing process? Wouldn't that be something that was
Yes, it is, isn't it?
That'll get you thinking. And then it's not just with humans or life forms. What about with stars? What about with... Oh, it's a playground.
It is.
And then think how many hands on deck you'd need to achieve something like that. I mean, in the beginning, life forms are few and far between, and, you know, tweak, 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 tweak to Lula. How many variations do you reckon? Humanity wants to look at life forms as a spectrum. Well, more of a spectrum. Yeah, there we are. Yeah, no? What's made up once can be made again and again and again.
Yeah.
But what would be the purpose? Keep making the same thing over and over again. You begin to predict it. But intelligence cannot be mapped. What if you have a life form from over there? You can just think about this inside your own universe now. Take a life form from over there and a life form from over there. Okay. It might not be compatible, but could I genetically look at these and find out where the incapability is? And then could I eliminate that incapability and eliminate this incapability, which either means excelling forward or dialing back, in order to try and combine these life forms together? And then ask you a question. Predict their intelligence. Predict what they would be able to do. But now, take a life form that you've had once before and predict what they can do. You'll be able to predict the destruction with fine art, and it usually stays on repeat. But the intelligence side of it is a little bit more elusive. It's a little bit more unpredictable. You can't really predict that, where it will go. Is that going to be true that all of the vessels on these life forms combining together experience? Not all of them are going to be super perfect. It would be nice if they were, but not all of them. It would be like trying to look at a tree, and that's if you don't play with it. Natural intelligence versus artificial intelligence. If you artificially intelligence put it into something, that's they run away with that, and then there becomes a problem with it eventually. There becomes a problem. But when it goes a little bit more helped. So let me give you an example. Genetically modified tree versus one that is left natural and given all of what it might need in order to survive better than any other tree. Do you get what I mean? So the sort of helping hand to sort of combine them together. So you could take two trees types and put them together, but leave them in a natural state, or you could genetically modify it.
Make them more resilient.
Well, if you genetically modify it, you'd make every single vessel perfect. Every single orange would come out on the tree perfect. But if you did it more naturally, wouldn't you have some that were a little bit more... But the taste of the orange, let's say, is much better when it's not genetically modified. The problem is the taste. It waters down.
I recall some strawberries that were made with some fish stuff not to freeze.
That's if you were eating it. Now, I mean, that's the outcome if you're doing it with fruit. But if you're doing it with intelligence,
Mm.
you sort of get a baseline
Yeah.
and it stays.
Mm-hmm.
Naturally, well, it's hit and miss, really, isn't it?
Yeah.
But it's not to say that the fruit that is less or more different to the other, it doesn't mean that this one doesn't have a purpose, because where it might be too sweet for humans or too sour for humans, might be just right for a wasp, might be just right for the ants, it might be just right for whatever else may live off of that.
Mm-hmm.
Because if you don't want that, well, you've just picked it down. Nature might already know what it's doing.
Yeah.
It knows that it's not just wanting to feed your belly. It also wants to feed the bellies of the insects, the birds, or whatever else, right?
Yeah.
So when you genetically modify something, are you really making that more so for you?
Mm.
So, and yeah. So anyway, so there are my questions. That's where I was coming with that. I'm going to go and get on because. So fission. I never actually say that word correctly.
Mm.
The fission, fusion. Don't like it. Hate that word. It's just
yeah, me neither. Me neither.
I mean, it sounds so ugly when you say it like that. I do apologize, but that's just the way it is.
Yeah.
So yes, Terra, the Earth, would be a really interesting experiment, wouldn't it? So once you've taken all of that carpet of life off of the Earth and put it onto something else, if you want to, and you move away from this solar system, let's say, Earth is going to be looking very basic. If you were to move the Earth away, would you experiment with it by adding more and more and more mass to it? Would you try and help it hit into a fusion process? It would become very sacred, wouldn't it?
Yeah. But you wouldn't be able to live on there anymore.
No, you wouldn't be able to live on, but you'd be able to live around.
Yeah. So you have to first
So you would upgrade.
Yeah.
But would humans experiment with that?
No.
The answer is yes, absolutely.
Yeah.
Look at your past. What have you not experimented with? Glass! Technically glass. You've never made glass buildings because you always say don't throw stones.
But there are sort of glass bricks, aren't there?
Oh, I like those. They're very good. Yeah, I like those.
And there are buildings that have glass all around.
Which ones are these?
So maybe they are not all made of glass, but they appear to be glassy, like some skyscraper.
Yes, technically.
Yeah. So
not
it's
really,
an illusion.
It's not made out of complete glass.
Yeah, no, that's what I'm saying. It's an illusion.
So the glass age, beautiful.
Yeah.
Beautiful. And I guess that's because of the pressure, which you can alleviate the pressure by using a balloon system also encased in glass. Weird. Allow something to expand within it. But again, I don't know if you could do that. You wouldn't need the protection around it, but still. Interesting. To remove the pressure in order to save the structure, which is interesting again. Where was I going with that? Oh yes, so you would make the star what?
What you would make the star?
Well, I'm just going to leave that as you would make the star into what? Question mark. Fill in the blanks. You'd convert the Earth into what? A star? So it would go on. I mean, that's a hell of a story. That's a hell of a story. And the moon would become something else as well. I mean, again, impressive. That would be impressive. But still, when I'm looking at Jupiter, this whole... As if the Earth has become sacred, or is it just a disrespectful dumping ground that didn't mean anything? And nature, would that become sacred? Animals, would they become sacred? Or will it just be genetically modified and that's it, just humans and a few?
That's a question.
Not really impressive. Very interesting intelligence. I like that idea or understanding of it. Very good. And CMEs, if they were to hit the nuclear power stations, what's the result of that? What happens when you start? And then what happened at Chernobyl? Was it really a test of flipping a switch somewhere? I mean, there's a lot of mess to go and investigate in. Was it the flipping of the switch, or did some sort of CME hit at the right time? Concentrated, whatever.
Who knows? They say that there were many steps that were not followed, but who knows? Only people who were there that had some idea.
Hmm.
But it's still melting inside, isn't it?
Yes. Reaching its way down to the core, isn't it?
Is it the elephant foot or whatever it's called? That's going down through the layer.
Hmm. Anyway, I was just offloading this one as just a little bit of creating a bit of space because this has been rattling around. It's just something I was thinking about. And then it poses a question for AI, space, which is the... And then spacecraft. You don't need electronics to get you into space. If all your equipment failed, what would you do? Neil Armstrong proved this. ERS, Earth Return System, wasn't it?
If you rely on something that can be damaged, then there is a problem, isn't there?
If you were relying on electrical and AI or whatever else, it wouldn't think that up. I'd take a human, and then it'd have to be reprogrammed really hurriedly. Sort these files for me. Okay then. Good. Good computer. And then what safeguards? I mean, I'm not sure how robots are going to cope with really cold temperatures. Probably not very well.
Yeah, the metals do not cope very well, do they?
Very brittle in these types of conditions, yeah. And then if it gets too hot, God, they're so fragile, aren't they?
Yeah, and plastic the same, so I don't know.
Then CME, interstellar space. Well, we're still getting signal from Voyager, isn't it?
Yeah.
Then the other Voyager came back online, didn't it?
Did it? I don't know, I don't follow that.
Very interesting. Anyway, you must leave me to eat my oranges now.
Okay, I'll leave you to eat your oranges and I turn it off. Yeah?
Yes.